Hello, I'm Maryam Alizadeh from the University of Victoria, and I'm presenting our work on durability estimation of bioprosthetic heart valves, or BHVs, via motion symmetry analysis. BHVs are routinely implanted to replace defective heart valves. Tears and calcification are the main sources of failure, mostly happening in areas under high localized mechanical forces. Currently, BHV designs are mainly tested through mechanical simulation. One of the well-known testing devices is the pulse applicator by Vivitro Labs that simulates the physiological cardiac conditions and flow patterns. We can also record high-quality videos during the tests, such as this one. In this study, we take advantage of this available visual data and use computer vision techniques to evaluate the motion of leaflets. This allows us to investigate the correlation between the visual symmetry and the functional symmetry, in other words, the velocity and vorticity parameters, and to search for areas under localized mechanical forces along the leaflet borders. For the visual symmetry evaluation, as there are 3 leaflets per valve, we consider 3 pairwise reflection symmetry cases. We start with the segmented orifice area and extract its contour, which we split at the anchor points to get the 3 leaflet border curves. 3 pairwise leaflet groups are then considered as shown here. The DOPM and DTW scores are then calculated for each pair. For the functional symmetry evaluation, we simulate the same valve orifice information and some boundary conditions to estimate the velocity and vorticity profiles along the leaflet borders in one cardiac cycle. These 2 sets of results are then compared to see whether there is a correlation between them. DOPM stands for Diagonal of Orthogonal Projection Matrix. The DOPM descriptor has been used in the literature for contour matching and reflection symmetry detection. We compute the DOPM descriptor for all points on both leaflet curves and calculate the DOPM score as the average of the differences in DOPM descriptors between corresponding points. Here you can see an example of DOPM score calculated for an entire cardiac cycle. The smaller the score, the higher the symmetry. Regarding the DTW score, the dynamic time warping method measures the similarity between 2 sequences by finding the optimal match between 2 curves that yields the minimum summation of the absolute distance between corresponding points. We superimpose the 2 leaflet borders by flipping one about the known symmetry axis and compute the DTW score. In this figure, you can see an example of DTW score and how the values are the smallest when the valve is completely open and has a more symmetric shape. For the numerical simulation part, a simplified computational structure based on the pulse applicator device is simulated by using a particle-based fluid numerical model, the dynamic valve opening, and the boundary condition as input to the simulation. This figure shows an example of the simulated crosswise velocity at the border of each leaflet pair. And for our dataset, we have 3 tricuspid valves with different designs mounted in the pulse applicator device, and 4 high-quality videos, 2 of them recorded for the same valve at different stages of durability testing. We qualitatively compare the calculated symmetry scores and simulated velocity and vorticity parameter profiles. As it can be seen on these representative graphs, the DTW score in the second column are in good agreement with the simulated velocity and vorticity parameters. They have the same trend and peak locations. That's not the case for DOPM scores. We also quantitatively assess the agreement via the root mean square error. The RMSE values between the DTW and the velocity and vorticity parameters are lower than those for the DOPM score and go as low as 0.09, which suggests that DTW is a good indicator of functional symmetry. To summarize, visual symmetry analysis was performed via 2 different symmetry scores, DOPM and DTW. Numerical simulation of the BHVs showed that the asymmetry in leaflet motion, as given by the DTW score, is coherent with the functional asymmetry of the valve, based on the flow patterns and the amount of stress on each leaflet. The established correlation between the visual and numerical results paves the way towards durability estimation of the BHVs using CV methods. Thank you.